Bohr's atomic model, the postulates. Bohr's atomic model has 4 postulates. Postulate ni dia macam theory. Bohr's atomic model explains about hydrogen atom. We can imagine hydrogen atom like this. This is the nucleus of hydrogen atom. As we know, hydrogen atom has only one electron, so this is the only electron of the hydrogen atom. According to postulate 1, electron moves in circular orbits around the nucleus. That means, electron ni dia bergerak dalam orbit yang membulat di sekeliling nukleus. When moving in the orbit, the electron does not radiate or absorb any energy. That means, masa dia bergerak mengelilingi nukleus ni, elektron tu dia tak memancarkan apa-apa tenaga dan tak menyerap apa-apa tenaga. Next is postulate 2. The energy of an electron in a hydrogen atom is quantized. Quantized mean fixed amount, jumlah yang tetap. That is, an electron moving in an orbit can have only a certain amount of energy. Dalam sesuatu atom, garis putus-putus ni kita panggil dia sebagai energy level. So, energy level yang paling dekat dengan nukleus kita panggil dia n is equal to 1. Yang kedua ni we call as n is equal to 2. Dan yang ketiga ni, we call as n is equal to 3. Energy level ni, dia bukan setakat n is equal to 3. Dia boleh ada sampai n is equal to infinity. Elektron yang bergerak ni, dia ada energi dia sendiri. Dan energi dia tu quantized, tetap, tak berubah. For example, elektron yang bergerak pada n is equal to 1, the energy is always fixed at negative 2.18 times 10 power of negative 18 joule. Kalau elektron tu bergerak pada n is equal to 2, the energy is always fixed at negative 5.45 times 10 power of negative 19 joule. Dan kalau elektron tu bergerak pada n is equal to 3, the energy is always fixed at negative 2.42 times 10 power of negative 19 joule. Since kita dah faham energy elektron ni quantized, fixed, so macam mana value-value energy ni boleh kita kira? Energy of an electron in its level can be calculated using this formula. En is equal to negative RH 1 over n squared. E ni energy, n ni adalah energy level lah, n1 ke, n2 ke, n3 ke, so on. RH ni adalah Rydberg constant, this is the value. N dekat sini adalah energy level lah, ataupun kita boleh panggil dia sebagai principal quantum number. Kalau kita nak kira energy of electron dalam level n is equal to 1, masukkan Rydberg constant dan n dekat sini 1, so dapatlah value ni. Next is postulate 3. At ordinary conditions, the electron is at the ground state, which is lowest energy level n is equal to 1. That means pada keadaan biasa, elektron ni dia berada pada ground state. Ground state ni adalah energy level yang paling rendah, which is n is equal to 1. If energy is supplied, electron absorbs the energy and is promoted from a lower energy level to a higher one. That means kalau ada bekalan tenaga, elektron ni dia akan serap tenaga tu. Bila dia serap tenaga tu, dia akan mula bergerak daripada energy level yang rendah kepada energy level yang lebih tinggi. The process is called as excitation. Proses elektron bergerak daripada energy level rendah kepada energy level tinggi tu dipanggil sebagai excitation. Energy absorbed by the electron during the transition from lower energy level to higher energy level can be calculated using formula delta E is equal to RH 1 over n initial squared minus 1 over n final squared. RH is Rydberg constant, N initial adalah energy level before the transition, and final adalah energy level after the transition. The last one is postulate 4. Electron at its excited state is unstable. Excited state ni adalah energy level selepas proses excitation selesai. For example, electron tu excited from n is equal to 1 to n is equal to 3. So n is equal to 3 ni lah kita panggil sebagai excited state. So electron yang berada pada excited state ni sifatnya adalah tidak stable. It will fall back to lower energy level and releases a specific amount of energy in the form of light or photon. Elektron yang tak stable tadi tu, dia akan fall back, jatuh semula ke energy level yang lebih rendah. Dan masa dia jatuh tu, dia akan memancarkan photon. Photon ni apa? Photon adalah energy in the form of light, tenaga dalam bentuk cahaya. Energy emitted iaitu tenaga yang dipancarkan masa elektron to fall down, atau kita boleh panggil dia sebagai energy of photon. Tenaga photon ni kita boleh calculate menggunakan 3 formula. The first one is delta E is equal to RH 1 over N initial squared minus 1 over N final squared. The second one is delta E is equal to H nu. H is the Planck constant, nu is the frequency. And the third one is delta E is equal to Hc over lambda. H is the Planck constant, c is speed of light, and lambda is wavelength. Since photonnya adalah cahaya, so we can calculate its frequency and wavelength. Frequency can be calculated using formula nu is equal to c over lambda. Wavelength can be calculated using formula 1 over lambda is equal to RH 1 over N1 squared minus 1 over N2 squared. This is the summary of 4 postulate of Bohr's atomic model. Untuk exam, cukup you all memorize ayat ni sahaja. Thank you for watching.